This unit is organized into two lesson sets. The first one, we really focus on how does electricity transfer through systems to power communities and what could cause instability in these systems. And then in the second lesson set, we get to focus on design solutions that could improve the electricity systems in our communities. But we are using a tool to keep track of engineering ideas throughout the first lesson set that will inform the decisions that we make in the second lesson set. So they are very closely tied together. And that gets us thinking about what we want to change in our community and how we want to set our community up for success. So in lesson set 2, we're thinking about what design solutions could improve the electricity systems in our communities. And you'll notice that in the first lesson set, we're focusing very much on reliability, and reliability really is the major concern that we have throughout the unit. But this question is purposefully vague because students might be more concerned about other things other than reliability or in addition to reliability. So improving the electric systems in our communities really is going to be up to students determining what is important for their community in terms of what they want to see in an electricity system. So in lesson 9, students are going to develop and revise energy transfer models to represent how batteries can make electric grid systems more reliable. They're going to quantify how much energy was needed to prevent the energy crisis in Texas and realize that, whoa, that's a lot of batteries. We use data from energy storage solutions to calculate the number of batteries needed and the costs associated with adding those batteries to the system. And we wonder about the costs from design solutions that are not financial. So we're going to think a lot about financial solutions, and we're going to wonder about what other costs might be inherent in adding batteries, particularly chemical batteries, to a system. And we're going to read a little bit about that in the next lesson. So if we go to the next lesson, in this lesson, we're really thinking about trade-offs, what decisions we need to make to design more reliable systems to meet our community energy needs. We're going to read about trade-offs associated with certain energy sources. And these trade-offs are really tricky. There are not simple solutions. For example, a hydroelectric dam, which is in this photo, seems like a really great solution because it can generate an enormous amount of power, and it is also not something that's contributing greenhouse gases to the environment. However, it makes a huge impact on ecosystems, and there are indigenous groups who are fighting against hydroelectric dams because it's destroying their way of life. So we're going to read about a lot of these very complex trade-offs. And we're going to read about them from the perspective of different interested parties. So we're going to read quotes from interested parties, and then we're going to develop and carry out an interview protocol to capture the values of people in our own community. So we're going to do a much more structured interview than we did in lesson 1, where we actually think about what do we want to ask people about, what do people value. We now know a lot about engineering design, so what are the constraints that people care about, that kind of thing. We're going to capture that with this interview protocol. And we're going to begin developing a plan for improving electricity infrastructure in our community and what we want to advocate for. So in the last lesson, we're going to use this tool, which is called the Energy Grid Calculator, which is a computational model that has been modified for our local context. So teachers are given directions on how to modify this tool so that it has the information from our community. And they use that to measure the success of our solutions against a variety of criteria. We describe our design solutions to our classmates using this energy grid calculator. It allows us to say, I want to demolish this many power plants, and it gives us a whole bunch of data on what that would look like and what the trade-offs are. And it allows us to think about which constraints do we want to focus on and why. So we present that and we give each other feedback that we use to refine our designs. And finally, we return to our driving question board. We celebrate our progress in light of all the questions that we can answer now. And we work through an assessment task. This is one of 2 transfer tasks that are embedded in the unit, in which we explain energy transfer in a solar sand power plant. And we use data to evaluate the feasibility of using this technology to provide reliable power to a community. And that all adds up to 11 lessons and 28 days of instruction. So we're back to this graphic here.